Hello, I'm Robert for fact-checking and science blogging for Doomsday Debunked on Facebook, helping people who are scared of many things. So I'm a voluntary fact-checker basically. I'm trying to help you if you're very scared. And a lot of other voluntary fact-checkers in our group. And so this is about the WHO who have just been very badly misreported by some news journalists, saying they reversed their decision about whether COVID-19 is airborne. They just don't know yet. And they don't know in the sense that the evidence is just not there yet. And so I mean, this is an example of being misreported. WHO reverses, says it can be airborne indoors. It's not really what they said. They said that some research suggested the possibility, but they said it could not be ruled out. They didn't say that it does happen. And this is very striking because after 12 million cases of COVID-19, we still don't have any research that is absolutely proving that it is airborne. Very early on, SARS and MERS, they discovered it's airborne. Like the Flight 112, Air China Flight 112 from Hong Kong to Beijing, 3-hour flight. One person got on it with SARS. 20 people got off it, infected with SARS, some up to several meters away from them, well beyond the possibility of the droplets getting to them. And 2 of the air crew got it. This sort of thing has just not happened for COVID-19. Then the WHO also gave very striking evidence in their report in a science brief just now. They have been advising health workers all along, looking after health care workers, and what they have said is that you don't need to use N95 masks unless you don't need to have these respirators, you don't have to be completely covered unless you are looking after people who are on intensive care and being intubated. And all the other health workers have just been looking after people in general wards with COVID-19. Like for instance Boris Johnson, I don't think he was intubated. He went into hospital, he was there for a few days, he was dependent on the nurses to stay alive, but he needed oxygen. So it was just oxygen. I don't think he was intubated. So if you were in that situation, I think you'd still be in a general ward. I don't think, unless he went into intensive care, possibly he did. I don't know. But if you're in a general ward and just getting those oxygen things around your nose, still able to talk and just in a general ward with other people, then you'll just have nurses around you with clinical masks and a visor. They're not going to be all suited up with the N95 mask. And the WHO say that these health workers are just not getting infected with COVID-19. So that is very clear. That is very clear. Because clinical mask will never, if it really is airborne, so there's the big droplets that just come out and fall down, and the clinical mask and the visors will help protect you from those. If you're up close to a nurse, to a patient, and they just cough in your face, then that'll stop it. But if it's coming out with the breathing, there's no way that the clinical mask will stop it. Just get in. And there's no way that the visor will stop it either. Just come out and go into your eyes. So it is absolutely clear that it is not airborne in healthcare settings. So if you are in a situation that is so keeping a distance of 1 meter is absolutely fine. The nurses only need the visors and the masks, clinical masks, because they have to go closer than that to help their patients. They can't do the physical distancing. They can't just say, oh, I wonder what's wrong with your mouth. I have to look at it from 1 meter. They can't do that sort of thing. So I've no idea what nurses do. I'm not a nurse, but whatever they do. And so this I've got to look in your nose or your mouth or something to check something. They can't do that without a mask and something to protect themselves. So there's only what. In normal situations, you're not going to be in a worse situation than a health worker in a COVID-19 ward. So just keeping 1 meter away from people who might have COVID-19 will protect you. Now, there is one situation where it might be that it's airborne, but the evidence is inconclusive. So, and that is that if you are in a crowded bar or crowded après-ski chalet, which is where a lot of people in Germany got it, or there's this choir, and if you people who got it in a choir, if you're in a small crowded situation, lots of people producing lots of droplets and very poor ventilation, in that situation it might be possible, but they don't know. It's not proven. It's inconclusive evidence. This is the actual brief itself. And so I look at that airborne situation, and they say that the physics of exhaled air and flow physics generate hypotheses about possible mechanism, and then so you've got a theory. So these are hypothetical. And when you breathe out, you do produce lots and lots of tiny droplets. And so a susceptible person could breathe these in. We're talking about very microscopic droplets here, less than 5 microns. That means about the size of a large bacteria. Too small to see. And so the question is, we definitely produce, just breathing, I'm producing loads and loads of tiny, tiny droplets that spread out into the atmosphere. And these droplets are the size of a bacteria or smaller. So the question is, can I infect someone with that if I have COVID-19, which I don't? I know I don't. I'm not in contact with anyone. But so if they have, so the question is, if there are enough of the droplet nuclei and that evaporate to make aerosols, so some of them are the big droplets that evaporate on their way out, little bits, not the very biggest ones, small ones evaporate and become tiny droplets eventually, and then off they float. And other ones start off tiny. And the question is whether you've got enough virus in that to infect anyone. So, and then they talk about one study that looked at the droplets of various sizes that remain airborne, but they depend, and then so this is where it gets very technical, it's a technical report. And they say, however, the authors acknowledge that this relies on the independent action hypothesis, which has not been validated for humans and SARS-CoV-2. So that's a bit of a mouthful. What on earth does that mean? Well, what this means is that the hypothesis that a single virus would infect you. That's the independent action hypothesis, that one virus acting independently of all its pals would be able to infect you and cause COVID-19. And this seems unlikely. It doesn't happen with MERS or SARS and MERS. There you need several hundred to infect someone, to thousands, hundreds or thousands of viruses to infect someone. And if they go and look at the cases of the I'll go through this properly at the end. I want to go a quick overview of the whole thing. So I'll just explain properly, and I'll go back and do a bit of that, a bit more techie, and explain that more properly. So what shall I do? Yes, I'll go to the very end of the report, then I'll go back and explain these aerosol bit, which is rather techie. So here are their key points. Based on what we know, currently transmission is from people when they have symptoms. Current evidence suggests that transmission is primarily through direct and indirect or close contact, through infected secretions of saliva and respiratory secretions, or through their respiratory droplets. So just the droplets when you cough, sneeze, talk or sing. And then it can happen in healthcare settings with aerosol generating procedures like intubation, where they put a tube down your throat in order to ventilate you, with you unconscious at that point, under anaesthetic. And then some outbreak reports related to indoor crowded spaces combined with the possibility of aerosol transmission. So just the possibility, suggests the possibility, for instance, quiet practice restaurants or fitness classes. But it's likely that you can be contaminated by touching the surfaces, because it's known that surfaces do get contaminated. But there's no proof of that. But there's so it just suggests the possibility. That's all they say. It suggests the possibility. And in another place they say it's not ruled out. And can't be ruled out. Detailed investigation of these clusters suggests that, so they say that it can be ruled out that short-stay aerosol transmission in crowded and inadequately ventilated spaces for a long period of time with infected persons can't be ruled out. But that doesn't mean it happens, because detailed investigations show that droplet, like I just said, so if you look at the at-risk party, for instance, they were shouting and singing very, very close quarters. So obviously it could easily be the droplets. And you go and look at other things, like for instance with the choir, then they had tangerines, which they set out in that particular instance. It's not a controlled experiment. It's just people doing the messy stuff they do. And then the experiment, because it's just not ethical to experiment with infecting people with aerosols to see what happens. So you just look at what happened in the real world, and nobody does a controlled experiment. They do messy stuff. So for instance with the choir, then some of them washed their hands. They had the hand sanitizer to use on the way in, but some of them used it and some of them didn't. And then they were talking together, and some of them would be physical distancing and some of them not. And then some of them go and get these tangerines. And so that's always the problem with these messy physical situations. But it's certainly not very clear. It's not like in an airplane. It's only in these very, very messy situations where you have loads of people very closely crowded together that it happens. And those are situations where it's very difficult to disentangle airborne transmission from all the other things going on. So they don't find someone in this situation who says, oh, I did all the physical distancing properly. I went to this happy ski party, but I kept 1 metre away from everyone. And I made sure nobody came 1 metre close to me. I washed my hands thoroughly. I never touched my eyes, nose and mouth. And yet I got COVID-19. The trouble is that in these places, and people having alcohol in lots of them, and they just haven't found anyone who went to such a place and was careful enough so they can go and look at that person and say, oh, this person got COVID-19, and yet he took all the precautions. So they can't do that. So they just, so far they can't do that. Maybe you should try going, I don't recommend this, try going to a very crowded place, take all the right precautions, but don't use a mask, and then see if you get it. But no, don't do that, because you don't want to get COVID-19. That's the whole problem of it not being ethical to do those experiments. If it was ethical, then you could just go out and say, oh well, I'll voluntarily go out. I suppose a volunteer, I don't do it, please don't do it. I don't want any of you watching this to get COVID-19. So, anyway, so it's very difficult for them to investigate, because none of these people, they won't be able to find people who were careful enough in those situations. It's very, very difficult to find people who, in those situations, who are really, really careful, and are as careful as, for instance, Mira van Kerkhove and Dr. Tedros, who went off to China, and they spent ages there in the worst hit areas and came away and they didn't get COVID-19 because they were epidemiologists and experts and they were careful and they knew what to do and they did it. But it's difficult to find people who do that. So you be careful. All of you watching this, keep the distance, do it properly, don't go to those crowded situations, don't take lots and lots of alcohol, because it's difficult to keep careful in that situation. And if you absolutely have to, wear a mask. And then be as careful as you possibly can. And don't worry about getting tiny amounts. So that's the bit I'm going to explain now. So I'll explain about the tiny amounts. And so this whole thing, so now I'll go on to that technical thing. So I explained the main bit, that's the most important bit, and I've got to 15 minutes. I got the most important bit, what you have to do. So now I'm going to explain why. So the airborne transmission, then what they found basically is that, now where does it go? They found viable replication competent virus, but this was using high-powered jet nebulizers, and that is the equivalent to the intensive care units where the WHO know that you do need to take great care. So that was nothing really new, although it hit the headlines and lots of people saying, oh, this experiment has shown it's airborne, but the WHO had already recommended that intensive care units that you do have to take care and you do have to use airborne precautions. And then they had some studies, in the healthcare situation, where without the aerosol generating procedures, in those situations it's very difficult to find RNA. They report some found it, some studies found it, and others found no RNA at all. And no studies have found viable virus in air samples. Now, by air samples there, they mean putting the air through a filter. I checked on one of those references, and it means air going through a filter, so it would catch all those fine droplets. So they're not talking about air somehow purified of the droplets. They mean air with very fine droplets in it. And with those samples, then the quantity in RNA detected was in extremely low numbers in large volumes of air. And one study that tested to see if you could get viable virus, and they didn't find any viable virus. And most tested it using the PCR reactions, which is not necessarily indicative of replication in infection-competent virus. So basically, they have no evidence of viable virus from healthcare settings from these fine droplets. And one study actually looked for it and didn't find the viable virus. And that's about the healthcare settings, they didn't find it. And then these things are already gone through that passage. And then up here, so then an experimental study that quantified the amount of droplets of various sizes go to really, really tiny ones. But the authors acknowledge, and then they say that if you have the independent action hypothesis, now you won't know what the independent action hypothesis is, but that's the hypothesis. Oh, I think I explained that. So I'll now explain properly what the independent hypothesis, action hypothesis means. This bit. So I explain in my article. So the thing is that this is the hypothesis that a single virus can infect a human, and this has not been demonstrated for humans and COVID-19. And so many viruses, and a single virus just doesn't get in. You need lots and lots of viruses, all their pals, to gang up, to get into and invade someone. So the thing is that a virus is not like a microbe. And even with microbes, even with anthrax, then a single anthrax particle in theory could make you infected, but in actual practice, they did studies, it's very difficult to find an example of someone who got infected by a single anthrax particle. Usually it's lots and lots of anthrax microbes in order to overwhelm your body as well. even though the anthrax can sustain itself in your body. So it's the same with anthrax too, actually, that it's not actually, I think, theoretically, a very small number of anthrax particles can give you anthrax. But it is really quite difficult, and usually, most cases of anthrax, it's large numbers of anthrax particles. Anthrax is a microbe. But then if you go to a virus, anthrax can reproduce by itself, but now a virus can't reproduce by itself. So a virus has to get into one of your cells before it can reproduce. And your cell does. We have the modern cell, the very early cells, very, very early life. Then it had no barriers to protect anything. Anything could go in and out. So if you could get a virus to some very early cell from early Earth, your first 100 million years or something, probably whenever it was, the early life was, the virus just goes straight in. But a modern cell has built up huge, huge numbers of protection devices to keep stuff out that it doesn't want in. Then it has little special receptors on its surface, sort of like little door keys. So things that need to go in, they go and press this key and go in. And then the cell kind of makes a little dimple, and then a little vacuole, little cell that goes into the cell, and then it opens, and then it opens up inside the cell. So the whole process to bring things into the cell. So it sort of opens up, thing goes in, the thing hits, it touches it, activates this receptor, creates a little dimple, and that's the ACE2 receptor that the virus gets into the cell with. Then the dimple gets bigger, and then it forms a little neck, and then splits off a little vacuole that gets inside, or whatever you call it. I think you call it a vacuole. I'm not an expert. And then the vacuole dissolves and opens up, and then the virus gets into your cell. And your cell has that mechanism to get good stuff into your cell. But your virus sneakily pretends to be a good guy, and goes and triggers and knocks. And it's got the right key, and it sort of knocks on the door and opens the key, and the cell says, yes, good, come in. And then it goes in, and then it infects. So the virus has to do that in order to, because it can't, the virus, unlike a microbe, can't replicate by itself. It's just a little smidgen of RNA and proteins and some sugars to cover it and sneakily hide itself from your immune system. And then it has to get into your body, and then it has to hijack the whole replication system you've got inside your body before it can make more copies of itself. Then once it gets into your cell, not just your body, into your cell, then it fills your cell with bits and bits, with lots and lots of copies of the virus. It just makes your cell go crazy and make lots and lots of copies of virus, absolutely useless to the cell. It just hijacks the cell mechanism to make loads and loads of copies of the virus till eventually the cell bursts. And then all those copies go into either your bloodstream or your lungs or wherever the virus is. So the thing is, can a single virus pop up to a cell and trigger the ACE receptor and then get into it and then create lots and lots of copies? And that's the independent action hypothesis. Or does your body stop it? And the thing is, and your body has lots of ways of stopping it. It can detect a virus before, even if it gets in, your body can still destroy the cell before it's able to make all these copies and go off. Because your body, the immune systems, these T cells that come around, they notice the cell it doesn't look quite right, There's something wrong with this cell. Better do something. Boom. Killed it. And then it just kills the cell and it can't make any more viruses. So that's what some of the T cells do, for instance. They just look at the cell and it doesn't look right from the outside because it starts making lots and lots of viruses inside. It doesn't look like a normal cell on the outside. So the immune system will zap it. So anyway, so the big question is, can a single virus get into your immune system, into your body, given you've got this very active immune system that's constantly looking for viruses? You've got hundreds of thousands of viruses come into your body every day, and your immune system killing them all. So, can a COVID-19 virus, amongst this very active immune system, get in? And so generally, and then this nice analogy from Professor Wendy Barclay, that it's like, I imagine it's a common analogy, and I've gone with it to explain it better. So generally, the outcome of infection, when you get severely ill or mild cold, can sometimes be determined by how much virus actually got into your body right at the start. It's all about the size of the armies on each side of the battle. Very big, large virus army is difficult for our immune systems army to fight off. So if you get a big blob of hundreds and hundreds and hundreds of thousands of viruses, it's like a huge army gets into your body, then your body starts fighting back. But the viruses all, by then they go around, they find lots and lots of cells to infect, then the infects make lots more viruses, so your immune system is creating more copies of itself, but the virus is also creating more copies of itself. So you come with 100,000, now you've got 1 million viruses eventually. And so you have these two viruses fight each other. And so if you start off with a big virus at the beginning, a big virus army at the beginning, then it's got a head start. And so that's why it seems with SARS and MERS and probably with COVID-19 that even if you do all this physical distancing, then you've got some tiny lapse, and then you probably won't get it. But if you do get it, you're likely to get the mild version because you start off with a very, very tiny army. And so then I use this analogy of the battle of the Thermopylae. So the viruses are like, so the Persian army, this is where 7,000, it was one of these famous last stand things, 7,000 Greek army held by a Persian army of perhaps 100,000 to 150,000. Contemporary accounts say 1 million, but historians say it's more like 100 to 150,000. And for 7 days of battle, 7 days including 3 days of battle, these Persians tried to get through this very, very narrow strait, the Battle of Thermopylae. I think this might be an image of the actual strait. So you can imagine an entire army of 100,000 people trying to get through that strait, and then 7,000 people stop it. So those people coming through just a few thousand at a time, that is like the viruses in the aerosol getting to you just a few thousand at a time, instead of a big glob all at once. Like if you have close contact and you have someone talking to you and shouting to you within 1 meter and singing in a chalet party, and that's like the 100,000 people, and there's no pass, it's all opened out, you aren't distancing, then you get these 100,000 people all coming in at once, 100,000 soldiers coming in fighting, and your immune army starts to fight back straight away, the immediate response. But there are too many viruses, and then it's got to try and learn what this virus is in order to trigger the antibodies, which only happen several days after you've even developed symptoms. So that's way, way down the line. The next response after that is you get a big temperature, you have your cough and things, and it's a long, long time before you actually get the virus-specific antibodies. So if you have the aerosol, and you just have these few viruses coming in at a time, then that's like the Battle of Thermopylae. And so these are the Greeks here, just 7,000 Greeks and all the Persians coming in, huge army, 100,000 Persians, and then these 7,000 Greeks, they managed to hold them off for entire 7 days. Sadly, eventually they all died. They were all killed by the Persians. It's a famous last stand thing, where eventually the Persians got through, but these Greeks were able to hold them off for entire 7 days. Just 7,000. So it's the same thing, but if it would take with the battle with you don't just have 7,000 of your immune system. Your immune system is continually making new stuff. So you don't have a similar situation that eventually, if it keeps coming in, that you're going to not be able to cope unless you have quite a lot constantly coming in. So that's the situation. So that is why it's not at all clear, just from the experiments, that they get these viruses in aerosols. Even if you've got a few viruses, like just 1 or 2 soldiers coming in, they're like the Persians. And so they don't know how many you've got to get at once. So just, if you've got 100,000 come into your body, but they take, 10 minutes to come in, it's not the same thing as them coming in all at once in about 2 or 3 seconds. Even if you've got 100 come in every every second. That's not the same. And then it continues for 1,000 seconds. That's not the same as 100,000 coming in all at once. So the big question is, how many have to come in at once in order to infect someone? Or over what period it can build up, and so on. That is just not known for COVID-19. It's very difficult research, and although we're 6 months down, this is very, very early days for such detailed understanding of a virus, a brand new virus. It's just very difficult. It's remarkable what they found out so far. So when the WHO say in this report, we need good research now, so they say that at the end. So don't feel that they are in any way belittling the researchers. This is very, very difficult research. So when they say at the bottom, urgent high-quality research is needed to elucidate the relative importance of different transmission routes, the role of airborne transmission in the absence of aerosol generating, the dose of virus required for transmission to occur, the settings and risk factors for superspreading events, and the extent of asymptomatic and pre-symptomatic transmission. So there's also the pre-symptomatic transmission. I'll maybe talk about that too. When I do a proper one, I'll go through the whole thing. So it's a very interesting technical brief. I really enjoyed reading it. Anyway, so that's that. So the Battle of Thermopylae. And so does it infect in crowded places? And the WHO just say they don't know. And this is the bit they said. Yeah, I read that out, I think. So all they say is that short-range aerosol transmission cannot be ruled out. Short-range aerosol transmission cannot be ruled out, particularly in specific indoor locations such as crowded and inadequately ventilated spaces over a prolonged period of time with infected persons cannot be ruled out. And that's how I talked to you about that. Then further, and then I've explained all that. And the urgent high quality research. So they don't do the research. They do some research, like especially in the field. They do a lot of field epidemiology. So like when they went to Wuhan and then searched all the way around China. But when it comes to laboratory research, they're they're funding people to do laboratory research in great detail, but they mainly are involved in these big Zoom chats with the experts who are doing laboratory research. It's you trained to be you are a particularly good laboratory researcher, and that's how it works. And so these people are very good laboratory researchers about what they found in these Zoom chats, and then they write their papers and so on. So they're saying that the research just isn't there yet to summarise, and so as I say, high quality research is very difficult to do, and especially so there are two kinds of research going on here. There's research in the laboratory and animal studies, but animals are not humans. Even recent monkeys are not humans, so they can't deduce everything from that. So there's a research in the laboratory, so they will take samples from humans, for instance, some of the cells that are in human bodies, in human lungs, human respiratory tract, and then they will artificially try and inculcate them with the virus and see how much virus it takes. And it requires thousands and thousands. Someone has done that experiment. It requires large amounts of virus to infect a cell in that artificial situation. But that's not the real world situation, but it does suggest that you need a high viral load initially in order to infect someone. That was a research I read a couple of months ago. I would have to search it up, but I remember reading it. And but anyway, they have to test that with different kinds of cells. And then, of course, in your body, you have the cells in different parts of your body, and sometimes there'll be small amounts, very little of these H2 cells in your respiratory tract. So what difference does that make? And if they could ethically just say, infect someone with an aerosol COVID-19, then the research would be easy. They would just take some human volunteers and just get someone else to cough in front of you, and who's got COVID-19, and they've quarantined you for 14 days first to make sure you don't have it. Then sit you in a room with someone who does have it, or they sit you in a crowded room with lots and lots of people, like in the bar, like I was saying earlier on. Don't do this. But if they were, you'd have to quarantine for 14 days first anyway, to do it properly, to make sure you haven't got it already. Anyway, so you quarantine for 14 days, and then you would go into this crowded environment, and they would tell everyone, just behave normally, but don't come within 1 metre of me, because I'm a test subject to see if it can be transmitted via the aerosol. And then you'd have all the people singing and doing all the normal stuff, but then maybe they'd have a kind of special barrier around you. And then they do that in places where there's known to be COVID-19, but even that's difficult, because how do you know there's COVID-19 there? I mean, you wouldn't have that crowded situation if you knew. You would have to actually infect these people with COVID-19. It's totally unethical. Infect people with COVID-19. Oh yes, I know how you could do it. Go to a ward of COVID-19 patients. Say to them, now you've got to go and have a big sing-song and produce lots and lots of aerosol. And then you get someone who's a volunteer who goes and sits in that ward and is surrounded by people singing and drinking alcohol and shouting and producing lots and lots of aerosol in a very, very close space. But you wouldn't want to do that either. I can't see any situation where this could be ethical, even if you had a volunteer, because that wouldn't be very good for the COVID-19 patients, would it? So I can't see any situation where even one human volunteer could resolve this. Quite difficult. Anyway, so they don't. There are situations. Sometimes you get human volunteers who deliberately put themselves in danger of a disease. It does happen. It's not impossible. And in this situation, might be especially some young scientist who says, "Well, I'm going to resolve this for once and for all. Go and try and infect me with an aerosol." It has happened in the past. Things like that. Again, if any of you are scientists, I don't recommend you doing it. No, you don't want to get it. But anyway, so short of that, then we're left with the very difficult piecing together the detective work with the what actually happened in real life. And or maybe you're just lucky and you find someone who was very, very careful about physical distancing in a situation where everyone else around them was partying in a closed place with poor ventilation, and they didn't wear, and the other people around them weren't wearing masks. I mean, that'd be quite a find to find a situation like that. And this person got COVID-19, of course. Otherwise, it won't prove anything. If they're very careful, didn't get it. And so anyway, so that, I think I'm finished on the Thermopylae and the virus and the virus at the time. So I'll just go into some of the other interesting things in this report. So I was very interested about the fomites. Go back here to the fomites. In another life, I could imagine becoming an epidemiologist. It's very interesting. I mean, intellectually interesting, and it's very important stuff that you're doing. Anyway, with the fomites, then as I say, there's it's very challenging. It's intellectually challenging, like a detective puzzle. I'm wondering how you would solve it. Anyway, so yes, this is what I was saying about how they definitely they found the virus on the surfaces. That is known. And depends on the ambient temperature and the humidity. Now, it can't be very spread by fomites. That can't be the main way of it happening, because this virus is independent of summer and winter. It's spreading in Arizona. It's spreading in very hot places. In hot places like Arizona, it won't last long on the surface. So it's pretty clear it's not spreading on surfaces very much. they're just contributing. I mean, that's another way of seeing it. You know, they are pretty confident all the way through this report. They're pretty confident the main way it spreads is via droplets. They don't mention that bit about what I was just saying about Arizona, but I think others have. But it's pretty clear. Yes, despite consistent evidence of a contaminating surface and the survival of the virus on some surfaces, especially on plastic. It survives for quite a long time on plastic. So it doesn't survive long on cardboard. So if you get something plastic from the shop, you should, and somebody might have coughed over it immediately before, you should have washed it. You should wash it if you want to be super safe. But they're saying they found no evidence of it being transmitted. So I was actually wondering about that before this report came out. You know, I hadn't seen any reports of anyone getting it through shopping. So we've got, during the lockdown, one of the priorities has been to shut all the shops. This is not based on evidence. You don't get super spreading events through shopping. It just hasn't happened. It's happened in pubs and in these, what you call, never by someone just picking something up and getting it from the shopping. And people don't talk much in shops. I don't think there are any cases of a super spreading event in a supermarket. Do correct me if you know of one. So, despite closing shops throughout Britain, for instance, all except essential shops were closed during the lockdown. That was not based on any science. It was based on science, but it was based on science by analogy with other respiratory diseases. It's known that it spreads the fomites on other respiratory diseases. So far, there's no evidence that it is spread that way for COVID-19. So, as we go through the research, as they find out more and more, it is entirely possible that they will prove that it couldn't be spread on shops. But they don't think so. They do think that it's a likely mode of transmission. It's just not been proven. But if it is spread in shops, certainly not super spreaders. You know, that is not the main way it's spreading. The reason we had these severe lockdowns, because they didn't know where it was, and it's so early with a very new virus, and they just say, we don't know if it spreads in shops, so we're going to close them all down. And it's the same with schools. There's so far no evidence of it spreading in schools as far as I know, but nobody wants to take that chance. And that's why this big debate, do we open schools or not? It's not as clear as it seems, because I don't think to this day there's any proof that it's spread in schools. For some reason, it doesn't spread easily from children to adults. Anyway, I'm getting a bit sidetracked here. So they're saying it's just not been proven. The reason being because whenever it has been spread in situations where it could have been spread by surfaces. There's a famous example in Germany where there was someone who had his back to someone else, and he just said, and this was a business, not famous, it's one of these ones that brought up in the papers and in the people talking about it, in talking about COVID-19. So there was this chap in Germany, and it was a place of work where they kept track of where everyone was seated at every time. And so they knew where everyone was and what they were doing all the way through. It's very tracked in Germany, very methodical place. And so this person, they knew when he had his break, when the other person had his break, when he left his work, when he was sitting in the canteen. And one person was infected, and there was only one time when the key case, the original case, there was only one time when he could have infected this other person. That was when they were in this canteen. And they were back to back in this canteen. And there's only one moment that he could have infected him, and that's when he remembered that he turned around and he asked, could you pass me the salt? And the other person passed him the salt. And it must have happened at that point, because it was the only connection. So that seems like it was probably passed on the salt cellar. But if you think about it, when he turned around to talk to this person and said, could you pass me some salt? They may have been talking within a metre. So I don't know how clear a case that was. That's the clearest case I've seen mentioned of where it might have been transmitted via fomite. But it can't be a totally clear case because they say that they say here they often have also have close contact with an infectious person, making this distinction difficult to discern. And so they say they don't know. There are no specific reports which have directly demonstrated fomite transmission. So this salt seller, presumably, when they looked at it very carefully at that paper where it talked about the salt cellar transmission, they must have concluded that it didn't directly demonstrate fomite transmission. So presumably they could have transmitted by talking. I'm just surmising as to how they came to that conclusion because it's not detailed. There are long discussions behind this, but they don't go into all that detail when they come to summarise it for the public like us. Some of it will be completely private research that has never been shared with anyone. That's how they do these systematic reviews. They also talk very privately to other governments sometimes. And anyone, that is the way the WHO work. They don't talk publicly unless the people who have talked to them have given them permission. So sometimes this is coming from things that they can't tell us because it's private. The research is not ready yet to be published. Or it is someone who's just talked to them privately and said, this isn't going to go any further. So that happens too. So the WHO are in the very best situation of evaluating this of anyone in the entire world. And the reason is because they do not blab. They never blab. And that's why people trust them. And that was why it was so unfair for Trump to say, you've got to blame the Chinese. I mean, what would they have said about Brazil, for instance? They always say kind and good things about Bolsonaro. They never say one bad word about him. Not once. They've been asked several times in the press briefing. I've never heard the WHO say a single bad word about Bolsonaro and the way he handled the COVID-19 crisis. They just never do that. So we had the other modes of transmission, urine and feces. It certainly is found there, but it's not sure. Again, there's no evidence. There's no evidence of being transmitted through the blood from a mother to the baby. But data is limited. Again, it's been found in breast milk, but there's no viable virus in the milk. So the WHO recommends that mothers with suspected or confirmed COVID-19 should be encouraged to initiate or continue to breastfeed. You don't need to worry, it doesn't seem to be transmitted that way. What else is it? They don't know the intermediate host. And yes, you can infect other animals like dogs, cats, and farmed mink. But it's not clear if it can be infected back from the mammals to humans. It only is known if it goes one way. It's not known if it goes the other way. Then there was a rather interesting bit about the symptom onset. That again, the viral load is highest. So the amount of virus you produce is highest when the symptoms start, right at the very beginning, just the beginning of symptoms. That is when you are most infectious. So if you feel even slightly ill, then that is when you are most infectious if you've got COVID-19. That is why they said even if you feel slightly ill, stay at home, even if you don't know whether it's COVID-19 or not. And that's the main reason for wearing the mask. Because if you, just before you're feeling slightly ill or when you're ill, on the other hand, it's not clear that it's not and then it gradually declines over time. So it starts low, goes up very high, then it declines gradually. That means it's quite high for a long time after. So it's not like flu where it is high at the beginning and then just decays away very quickly. It goes up high at the beginning, then it goes down very, very, very slowly. So, and the duration of positivity is 1 to 2 weeks if you're asymptomatic, up to 3 weeks or more with a mild to moderate disease. And WHO continue to say that you should isolate for 10 days, no, for 14 days after. I think they still say, but they're unless they've got updated on this, it's 14 days after all your symptoms have ceased, or until you have 2 negative PCR tests. And some countries have said it's okay after 10 days without a test, but the UK is a big outlier there. The UK says you're okay after 7 days. If you go and look at the SARS, the SAGE report, it's very, very weird. I've never seen anything like it. If you look at the minutes, they say that they know that it can be infectious up to 14 days. They think it could be infectious up to 14 days. And then they say, but with our models, then it doesn't make much difference if they isolate for 7 or for 14. So we're going to recommend 7. That seems to be their reasoning. And it's not it, and then, but this has been changed on his kind of the whispers, what they call Chinese. I don't want to use that word. Maybe it's a bit racist. I don't know. But we have this game called Chinese whispers. I don't know why it's called Chinese whispers, where you say something to someone next to you, and they say someone else. They say to someone else. It goes all the way around the circle, and it comes back to you. And the funny thing is, when it comes back to you, then you then say what you were told, and then what you actually said originally. And then people laugh then at the difference between the two, because you're just whispering. So this is a little bit like that. The original SAGE report in the UK, then it seems if you go way back to the original minutes, and the minutes are now published, it looks as if there's nothing there about anything else anyway. They said very clearly that it's infectious, thought to be infectious, that flu is infectious for 5 days for adults, 7 days for children, but COVID-19 is probably infectious for longer. And then they did modelling, and in the modelling 7 days and 14 days had similar effects. And then, but their modelling isn't very good, I don't think, myself, because it was based on the assumption it's airborne, which isn't very well founded. As we see, it's only airborne in very, very specific situations, not in a shop or whatever. Anyway, no matter about that. And then when you go to the NHS, they say you're not infectious after 7 days. But if you go back to the original SAGE report, it doesn't say that. The original SAGE report, way back, that all this is based on, says that you're probably infectious well after 7 days. It says that flu is infectious for 7 days, but with COVID-19 you're probably infectious after that. So it's very strange. I don't know why the UK is going by this, because it's not human. You know, people want to know, when they want to know when should I stop isolating, they don't want to know when is a time that is good enough according to a model. If you want to optimize, you're not worried too much if I infect 1 or 2 people as long as it's rather rare. Their model wasn't good anyway, because it probably wasn't taking account of it staying high for a very long time, not just being present for a long time, but even being high for a long time. It wasn't it was just model, it wasn't real based on real life evidence. Anyway, the evidence is knowing that knowing when an infected person can spread is important. Knowing how it spreads. The WHO has got a new brief, so I would have to look at that. But as they said, even for the mild case, you're certainly producing the virus for 3 weeks or more, for up to 3 weeks with mild to moderate, and 1 to 2 weeks with asymptomatic. But the strange thing is that if it's asymptomatic, then it doesn't necessarily mean that you're infectious. It doesn't mean it's infectious and able to transmit the virus, because remember, it's got to be viable. And not only that, it's not just a few bit. It's not enough just a little bit of it is viable. You've got to have your thousands and thousands. Your thousands, probably thousands, would be needed. Hundreds to thousands, probably thousands needed, because it seems to be SARS and MERS. It was hundreds to thousands, but COVID-19 seems to require a higher load, so it's probably thousands to tens of thousands, maybe more. It's not so, there aren't so many of these ACE2 cells in your upper respiratory tract, so even if you manage to get into one of them, then it's not there's not many pals around to help it. So anyway, I don't know. The experiments I saw, and I don't think there's been an awful lot of work done on this, but the experiment I saw was saying that it required very high viral loads to infect the cells that they tested in the laboratory, which is not the same as testing in real life. But so the asymptomatic people, they have it for a rather less period, and they need to know they just don't know. So I think they don't mention there, but the best evidence seems to be from Singapore, that they tested just about everyone for COVID-19 for if they had flu-like symptoms. And that was enough to suppress it. How could that suppress it if asymptomatic people... You see, the thing is that serology tests are finding that 9 out of 10 people seem to be asymptomatic, or at least don't get, we're missing them, they get the antibody tests, they got mild symptoms. And if there's so many people like that just not being found with the testing and tracing, then how come that we managed to stop it with test, trace, isolate? It just doesn't make sense, unless those people that don't, because New Zealand stopped it, Scotland is stopping it. It has to be that the ones who are asymptomatic just don't infect people much. Otherwise, a test, trace, isolate wouldn't work so well at all, because you'd have these asymptomatic people infecting other people who are asymptomatic. It would have to happen at least a few times. You'd have someone asymptomatic being a super spreader, and that's not happening. You'd have to find asymptomatic people and asymptomatic then infecting symptomatic people. It doesn't make sense, because you can't isolate the asymptomatic people with test, trace, isolate, and if sort of half of them, or more than half, it seems, maybe even as much, more than half are asymptomatic. And if those asymptomatic ones start up clusters just as much as the symptomatic ones, then you're not going to be able to stop nearly enough with test, trace, isolate, because you have to stop 70% to get down to well below 1. And so if 50% are asymptomatic, it's just not going to work. So, and New Zealand is managing to get got the reproduction number down to a half, from 2.7 to 2.5 to a half. And you can't do that if a lot of the infection is from asymptomatic people. So it's pretty clear it's not being, the asymptomatic people are not infectious, and yet they do seem to produce a lot of virus. So that's a bit strange. Maybe the coughing is part of it. The asymptomatic people aren't coughing. Maybe it's something to do with where the virus is in the people. I don't know. They just don't know. So this is one of the interesting things about this. So there are lots of questions, loads and loads of questions if you go down this. So it is absolutely known that people without symptoms can infect others, but the extent of it is unknown, and it seems to be very low. Or maybe they do talk about that there. Oh yes. Oh, here we go. It's not 10 to 1. They've got a good result there. I haven't read this bit. I must have skimmed this bit. So, first of all, 75 to 100% of the asymptomatic people develop symptoms. And a systematic review estimated that the truly asymptomatic range from 6 to 41%. That means a systematic review of papers published on the topic, with a pooled estimate of 16%. But all the studies have important limitations. They didn't clearly describe how they followed up with people who were asymptomatic to test if they had symptoms. Others defined asymptomatic very narrowly. So asymptomatic wasn't, it could have been that they lost a sense of smell or taste, for instance, that wouldn't have counted as asymptomatic. So it's not very good advice. I had good knowledge. Recent study that was more carefully done said that the proportion who never developed symptoms was about a quarter, 23%. Multiple studies have shown people can infect others before they're ill. And one study showed, that's the study from Singapore, I mentioned that. So they do talk about it, I just missed this section. I didn't read the whole thing properly, I just read the bits I was interested in about aerosol transmission. I'm just reading this for the first time now. So 6.4% were from pre-symptomatic in Singapore. And another one estimated 44% may have occurred just before symptoms. And it's not clear why that was based on modelling. It's not clear why the modelling is different from the empirical data. I had to look at that modelling study myself, and it was actually, they're being a bit polite there, it was very distant from the actual data. It was using just a few parameters. I did an article, a blog post about it, I think. That modelling study was actually, yes, I remember, it looked at the time between being, you being symptomatic and the case you possibly infected being symptomatic. And it didn't look at the interval between when it didn't, and it estimated that as being the incubation period for the case that was, it didn't have the incubation period. That was the problem. This study they're talking about there, they didn't have data as to when the person was infected in most of the studies. So that made it very difficult to actually model. And so based on that, they were making loads and loads of assumptions, and then based on those assumptions, just not actually having the information, it wasn't. There was a meta study looking at lots of individual studies which just didn't have the information. That was that modelling study that said 44%. I remember the figure 44, and I'm pretty sure that's the same one. So I don't think that was a very good study, and that was a very, very good empirical. This one actually looked at Singapore, and it said Singapore, it came a big number, like about 50%, and the actual data on the ground with very thorough looking at the cases was 6.4%. So I think this modelling was just wrong. So I wasn't convinced by that study at all. So it seems that very little is actually coming from people without symptoms, even from that is pre-symptomatic, not asymptomatic. That is about pre-symptomatic people who went on to develop symptoms in Singapore, only 6.4%. Almost none. I don't think any came from asymptomatic people in Singapore. So it's a really interesting subject. I hope some of you, some of my interests in this has come through. So as I say, transmission can occur from people infected and remain asymptomatic. The extent of this is not fully understood and requires further research as an urgent priority. And airborne transmission also requires further study. And so, yeah, so I think I've more or less finished this. So, that doesn't really have much implication on, well, the main thing is that test, trace, isolate does work. Now, if you want to find the asymptomatic, now, if the asymptomatic ones were important, then that means you've got to test everyone. They do sometimes test everyone in a care home and in a hospital, and that does turn up the asymptomatic people. And it is possible that testing everyone, so the asymptomatic people, they think is only a quarter, so not 23%. I just read out that figure just earlier this page. So that suggests that you're mainly finding pre-symptomatic people when you test everyone, but you do find some asymptomatic people. So then if you isolate them all, the pre-symptomatic one, that's just like you could have found those by contact tracing, and the asymptomatic ones as well, come to think of it. So with only 23% asymptomatic, maybe that explains why the contact tracing works. Maybe they do infect people, but the contact tracing gets most of them, and then before they infect anyone. But it's so anyway, I think I've talked about everything. It gives me this 1 hour and 10 minutes. But I think I did get the main points in the beginning. And so the conclusion, it's covered through contact and respiratory droplets. It just said or potentially, but in a controlled medical environment, then in the intensive care units, then the aerosol generating procedures do cause airborne transmission. But with crowded, poorly ventilated settings, the short summer years, it is just so complicated, so much going on, and research just isn't there yet. They just don't have the magic example of someone who was in a situation where lots of people around them were getting drunk or singing and shouting, and they were able to say to the researchers, I was more than 1 meter away from all the way through. I washed my hands thoroughly. I didn't touch my eyes, nose and mouth, and I got COVID-19, and I didn't get it from anyone else. I was not in contact with anyone else before that event that I could have got it from. Remember, it's got an incubation period of up to 14 days. So if you got it just say a couple of days after that, that could be someone you got it from 12 days before the event. So it is very, very hard to actually prove these things, especially if it's happening in a situation where there's COVID-19 in the community. How do you know it wasn't someone that you were talking to 2 weeks ago and you've just forgotten about it? So it's really quite difficult research. And the WHO basically say we don't know. And we don't know what is the minimum, they don't know the answer to the Thermopylae thing. Basically, they don't know how many soldiers there need to be, how wide the pass is, how many soldiers there need to be to overwhelm your army of whatever it is that fights back against COVID-19 virus, SARS-CoV-2. So I don't know if the pass has to be a very narrow one and only lets one virus through. That seems very unlikely. Or if it's like wide enough for, say, 100, in fact 900 or something like that, then that might be enough for SARS or MERS, but it mightn't be enough for COVID-19. It mightn't be, it has to be wide enough to let 10,000 through, maybe even 100,000. Maybe the entire Russian army has to come through in order to overwhelm you. So they just don't know. If it's just a few, that is obviously an artistic exaggeration. it was like, it isn't quite as narrow as that, just 2 or 3. You can see these people, it must be so frustrating for them, just lined up behind each other, waiting to fight. And there's 100,000 of them in a queue, sort of waiting to fight with these 7,000 on the other side. And it seems they must have got to 1,000 of them a day. And 7,000 held them back for 7 days. And then eventually they got through. Anyway, that's what these are viruses. We're talking about viruses, not people here. And so these are like this is from this it doesn't mean anything about Persian. Sorry, if any of you are Persian, there's nothing. It's just an accident that it happens to be. I'm brought up in the UK, and it's just a thing that came to mind. I think there's another one called the Persian Gate or something, which is rather similar. I don't know if that's it's just that I happen to know about this one because people talk a lot about Greek history, and so I just immediately thought, oh, the Battle of the Well, I looked up in Wikipedia last stand, so I was thinking there was a Greek battle, I forget what it was called, and they said, oh, the Battle of Thermopylae. I said, oh yes, that's the one. There is another one. There's several other ones like that, so you can find others in other countries with other people, but there's just a few held back a large number. And it could be a bridge, or it could be a narrow ravine, or something like that. And or it could be a strait with just a few boats keeping back a lot. And so the viruses are like that. If it's aerosol, then it's almost like a strait with just little droplets coming in at a time. And they just don't know. They don't know how much there is in the droplets. They don't know how much is actually viable, as it could actually infect you. There's only one of the studies that measured the airborne in health settings, actually checked if there was any viable. It didn't find any. So it doesn't seem that they've actually tested the air in Swiss chalets, for instance. It seems a bit of a mess. You would think some researchers said, oh well, we'll go and but then they don't know this fact. The thing is, I suppose it's very difficult to do that study because they don't know, unless they have these filters in every single chalet and every single pub throughout the world. You can't go back in time and put a filter into the pub or into the chalet after the event has happened. So, and they don't know that the COVID-19 was there. And then, again, it would be unethical to let the event go ahead if you know there's COVID-19 in it. So, it's hard to think of a situation where you could actually create a situation that is an exact copy of what is happening in a Swiss chalet when everyone's singing, or in a choir where you have people with COVID-19. I suppose that's what the researchers could do. They could find, get a lot of COVID-19 patients and get them to sing very loudly in a small space without much ventilation. But then, would that increase the risk of you? I don't think it would. That might be a way the researchers could research it. I mean, as long as it doesn't increase the risk of COVID-19 people, maybe it'll cheer them up a bit. Sort of singing. Look for COVID-19 people with COVID-19 who are good at singing, and who are at an early stage. They've got lots of virus, and then have them singing away, and then put these filters up, and then see if you get enough of the actual viable virus in the filter. And then try using that to infect a culture with human cells in it, and then see if there's enough of the virus in the filter to infect just in the laboratory. That wouldn't be a complete answer, but it would be a start on this problem as to whether there is enough virus to infect anyone in a situation like that. But you wouldn't do it in a normal ward. You would say, we've got to put you into this rather badly ventilated place. We're going to close down we're going to shut off the ventilation for an hour or two, so it is rather badly ventilated, and then you all got to sing away, and then we're going to have this filter just sitting there, and then see how much COVID-19 virus gets into the filter, and then send that off to the researchers. The researchers would look at it and see if it's viable. I suppose you'd have to do something like that. Anyway, anyway, that research hasn't been done yet. So it's all very, very hypothetical. It's just, you say the evidence is it's very weak. And so you had this big letter of all these researchers saying, WHO, you've got to reconsider it. But if you look at what they actually gave the WHO to look at, it was very, very weak. That's the problem. So WHO, they said there was this thing about a restaurant. I remember in one article I read, it said, oh, this thing about restaurant, it seemed very clear to researchers. The WHO must have looked at that and said, but asked some detailed questions and said, is it possible that these people actually talk to each other within a metre, or could they have touched something that the other person coughed on? And then when they looked very carefully, they'd have found that was all possible. So these people sort of saying to the WHO, you've got to reconsider, but it seems that they didn't give them very strong evidence. And the WHO, so basically this is a tit-tat thing in a way, not in a bad way. So the researcher said to the WHO, you've got to reconsider. The WHO did reconsider, and they said, the high quality research isn't there yet. We're still looking for high quality research. So they're saying to the researchers, over to you, please, please, please look more carefully. Because we didn't find high quality enough research yet. So the research, it's over to researchers now, and they've got to do more of this very high quality research, which is very, very, very difficult to do, given the situation that they're having to research. So I hope they manage to do this research, and that we can get a bit clearer situation about this. Meanwhile, the WHO advice is that it is not, it's possible, it's not shown, it's not ruled out. So, but the advice is the same as anyway. Avoid those crowded situations, do keep a distance, wear a mask, that will help stop you infecting other people, that will reduce. If everyone's wearing a mask, even if it's crowded, even if people are singing, that will hugely reduce the amount of the aerosol going out. So that will reduce the number of viruses in these armies. So that's why they say about cloth masks. It's basically reducing the amount of virus. It's reducing the size of the Persian army. It's like the narrow slot. So that's why they have this advice of wearing a mask, a cloth mask, if you are in a crowded situation, and ventilate. That's like letting a lot of the virus out. So they're basically saying, in health working situations where it's well ventilated, there's almost no virus, sometimes there's no virus. Some of the studies find none, some find almost none, and it doesn't seem to be any viable in the only study that looked to see if it's viable. So keep it as well ventilated as a healthcare setting, and you should be okay, even if everyone in there has COVID-19, but keep it well ventilated and you should be okay. And also wear a cloth mask, and that will also help reduce the amount of virus. So that's their advice, but you want to avoid these crowded situations. If you are in them, you still want to keep 1 meter away. If you can't do that, you've got to wear the cloth mask. So that basically is the situation. But then do bear in mind that if you get a very small amount of the COVID-19 virus, then you are likely to get a much milder version of the disease as well. It's not certain. None of this is known. It's very, very early days. We will know better 2 years from now, 5 years from now, 1 year from now even. So it is really remarkable what they've found so far. Anyway, so I'll stop that now. It's really quite long, but I think some of you might be interested in this and listen right to the end. So if you did, then thanks for listening to the end, and then the usual thing. If you want to hear more of this, do subscribe to the channel and like it if you want to, and or share it. Share the video if you've got friends who think will like it. And welcome anyone, especially people who are very knowledgeable and want to help with fact checking, like I've been doing with this video. And do then you're very welcome to our group. I did this video. The thing is, I felt that I wanted a long, in-depth video for people in the group in Doomsday Debunked. So there's some people who like this sort of thing. And so, you know, I'm just doing it to help. Maybe a few will have stuck to the end. I try to say the most important bits at the beginning, and that may be what I do more going forward if I have a long one. So the main message is right at the beginning, and then I have anyway. So now I'll stop now. I've said everything. I'll upload it.